Okay, so today we're going to talk about BigLake, BigQuery's evolution towards a multi-cloud lakehouse. Lots of buzzword. Personally, like what Alex you said, I didn't like this paper very much because I feel most of it is just marketing, like discussions, not very useful technical details. There are some I try to extract them, but overall, I think I don't know. Most Google papers, from what I've seen, some of them are like this. They don't explain all the technical details, but also this one was, I don't know, from what I have read so far, this one was the most marketing paper that I have seen. So let's start with Google BigQuery. BigQuery was released in 2010, and what they call it is a fully managed serverless multi-tenant cloud data warehouse. So what it means that on top of their storage solution that they have, so Google has a storage solution, and they offer this data warehouse where people can like put all their data inside it, like typically like, do some kind of ETL to load the data into the warehouse. But the main key design points in this platform is that it has a disaggregated design. So it means that it has a separation of compute and storage. So this allows them for better scalability, and also like I've seen most data warehouse solutions use this kind of technique to separate the compute and storage, and works well for them because you can have cheap storage and like decouple the compute and storage layer. And also they mentioned that they have BQML, which is an embedded ML solution on top of Google BigQuery. So this was Google BigQuery at 2010, and then um, they talk about data lake houses in this paper. So I don't like I don't know all these buzzwords like data lake house, data lake, data warehouse. They're to me they're very much similar, and how I feel is that these names are only like marketing names. The underlying solutions are not that different. Of course, a bit different as we can see here. Like for data warehouse, what you had is that you have some structured data. You use ETL to load it into a data warehouse, and then you do whatever you want to do, which is BI, doing getting some reports, whatever analysis that you want to do. And then for data lakes, what happened was that they said, okay, let's not do the ETL part first because we don't know what will happen. So because we don't know what will be the use case, let's not decide on that from the start. What we will do is that we put everything in something called data lake. And in this data lake, then we will decide to use ETL however we want, load it into a data warehouse, or directly utilize this data lake house and data lake. But for data lake house, which I feel is very much similar to data lake, they offer metadata and governance layer on top of data lake. And it's kind of the same, but it's the overall trend that people have been moving to like Databricks. I've seen that they offer data lake houses and also Google. So I think this is how it has evolved from the data warehouse and now to the data lake house. And so BigQuery's architecture, as I said, has a distributed storage layer and also a compute layer on top. So Dremel is their query processing engine, and they have a distributed memory layer, and under all it is the distributed storage. So you can imagine something called like S3, but what Google has. And but for BigLake, what they try to do is that they try to add some features. The main claim about this paper is that they say our customers want different features, and we are trying to add those. And we have evolved BigQuery to become this BigLake architecture. And like at a high level, you can have your data in different clouds because they mentioned that we needed some kind of cross clouds. So customers want their data to be in multiple clouds, and then for the storage, you can have BigQuery native tables on top of this, managed tables, and also Iceberg table. So they also talk about all these open source table formats and how they wanted them to be the first class citizens in their BigLake architecture. And something else they talk about BigQuery is that they have a storage API that enforces security. They don't give much detail about how it works under the hood, but they say it has a read API and a write API, and with the read API, you can read some rows, and with the write API, you have streaming like data ingestion, and they also guarantee exactly once delivery, which still I didn't find how they do this. So and the important thing they mention about this is that they enforce security at this level. So you don't need to add security to your query processing engine or whatever. You can utilize whatever security you want to have at the storage API. And for the big lake tables, as I talked about, they want open source data lake tables as first class citizens because people have been moving towards all these open source data lake tables, open source storage formats, and they also want fine grained security, which means column security, data masking, row level filtering, all different kinds of use cases that their customers want. And as I talked about, they want security at the read API. So they don't want to like make the query engine complex. They don't want to they don't want the query engine to handle all these. The read API itself handles all these security features that they want. And they also mentioned that they do some kind of caching to have a better query performance because listing all the files on top of all these tables it takes a lot of time and they cache this information. Still, they don't discuss how they cache it, exactly what they do. And they also have BigLake managed tables, which you can have open source data formats like Parquet, Iceberg, uh, and also they offer the same read and write API. So from what I've seen, what they're trying to do is to have um, multiple underlying tables, but be able to communicate with them, like with those read and write APIs. And one other thing they add is object tables. So you need to store in unstructured files. So images, videos, whatever you have, documents, you want to store these. These were some features their clients requested from them. And what they want to do, one technical thing they mentioned, which was interesting, was that let's say you want to add all these object tables and do ML on top of it. So the problem with that is that ML workloads have big models, and also your data is huge most of the time. So what would you do for the workers? One thing you can do is to have multiple types of workers. For example, you have a worker type which has a lot of memory for AI workloads. That would work. But what they mentioned is that they don't want to do this because um, you have to handle lots of query scheduling stuff. So you have to say, okay, now this is an ML workload. It has to go to worker 12, which has a lot of memory, or if it's not, we won't need to use that one. What they do is that they load the data and the model on different workers to reduce the amount of information that they have to hold in the worker memory, and they only communicate the tensor arrays, which are much smaller. So this way they can do in-engine inference what they call it. And for external inference, so let's say you have an ML model deployed somewhere, they just call the API. They don't need to do anything smart about that part. And one last thing they mentioned is only if I read it right, what they want to have is a multi-cloud solution because their customers want it. It's what I don't think this is what something that's easy for them to do because uh, everything they have is built on top of Google infrastructure. But they mentioned that they ported all these things into different clouds so that the customers can use the same solution on top of, let's say, AWS, Azure, or whatever cloud. And what they can do here is something called cross-cloud queries. So they mentioned that they support cross-cloud queries. So if parts of your data is on AWS, parts of it is on Azure, you can, and parts of it on Google, you can like access all those different parts. They don't like get into the details of the technical parts about this. I think that would be interested to know more exactly what will happen under the hood because for performance, I think all these cross cloud queries can have a lot of impacts on the performance because you're going to multiple cloud and so in summary, this was the BigLake paper. It's how BigQuery evolved to this data lakehouse architecture. And I don't think from the technical point of view, the paper has much to offer. It's very much abstract, but it's interesting how what features they offer and how they evolve the solution when the customers ask them to like add all these features that they needed. For me, the cross cloud part was interesting because I don't think that's something they really wanted to do, but maybe their customers kind of indirectly forced them to do that, and that was interesting. But yeah, this was the Big Lake paper. I hope you enjoyed it.